Welcome to Lesson 06, where we cross the line from configuring Nginx to actually programming it. Up through Lesson 05, everything was directives, declarative config, but some problems just don't bend to that model. Verifying a JWT signature, rate limiting per user ID instead of IP, splitting 5% of traffic to a canary, rewriting a request body before it hits the upstream. Lua inside Nginx solves all of those in 10 to 30 lines with sub-millisecond overhead. Through 4 specific hooks, we'll spend the rest of this lesson mastering. Here's the map for the rest of the lesson. You install OpenResty. That's Nginx bundled with Nginx.lua, LuaJIT, and the standard library ecosystem. Nginx Extras is the fallback when you're retrofitting an existing install. From there, 3 hooks do the heavy lifting. Access by Lua for allow-deny rewrite decisions before content, content by Lua when Lua itself becomes the upstream, and shared dict for the cross-worker state that plain Lua tables can't give you. Master those 4 primitives and you can collapse entire sidecar services into 50 lines at the edge. Before we touch any code, you need this map in your head. Every request walks through 6 phases inside Nginx, and each IDE by Lua hook plugs into exactly one of them. Rewrite is for URL surgery. Access is your gate for auth and rate limits. Content is when Lua becomes the handler itself. Header and body filters reshape what's going back out, and log fires after the client is gone. Perfect for metrics without adding latency. Pick the wrong phase, and your code either runs too late to matter or too early to see the data it needs. Let's make the access phase concrete. 15 lines of Lua, and your backend never sees an unauthenticated request again. Pull the authorization header, strip the bearer prefix, verify the signature with resty JWT, bad token exits with a 401 right here at the edge, valid token gets forwarded with X user ID injected so your upstream just trusts and reads. One auth policy, one place, 0 CPU wasted downstream. Now shift from gatekeeping to actually answering the request. Content. By Lua doesn't sit in front of an upstream. It replaces it entirely. Health checks, version endpoints, metrics, cache clear hooks, IP to country lookups, 80,000 requests per second on a single VM, no node process, no Flask worker, no cold start. The rule of thumb is simple. Every one endpoint microservice orbiting your real app is a content by Lua block waiting to happen. Hook 4 is shared dict, the piece that turns Nginx into a stateful coordination layer. Stock limit rec only knows about IP addresses, which collapses the moment users sit behind NAT or share a corporate egress. Declare a 10 megabyte zone, grab the user ID from a header in access by Lua, and call incarar. Atomic, lock-free, shared across every worker. 100 requests per minute per identity, no redis round trip, no race conditions. That's the free upgrade from IP-based to identity-based limits. Now let's put these hooks to work on a real problem. A 5% canary deploy. 2 upstreams declared at the HTTP level. V1 stable, V2 the canary. In access by Lua, we hash the user ID with CRC32 and mod by 100. Buckets 0 through 4, exactly 5%, get routed to V2 by rewriting the backend variable, and we tag the response with an X variant header for debugging. Stable per user, no database, no feature flag service. Bump the threshold from 5 to 50 when you're ready to widen the rollout. Step back for a moment and ask the harder question. Why Lua at all? Why not just write this in your back end? 3 reasons. First, latency. LuaJIT compiles to native code, so an access by Lua handler runs in 50 to 200 microseconds. Pushing the same logic to a backend adds a full millisecond of Nginx plus network plus startup. At high RPS, that gap is the whole game. Second, centralization without coupling, auth, rate limiting, AB routing are cross-cutting. One place at the edge protects every service automatically. And third, know where Lua loses, business logic database access, stateful workflows, those belong in a real app. Edge shapes the request, backend owns the domain. With the why settled, here's the cheat sheet worth printing. 3 hooks and 4 APIs cover roughly 95% of the Lua you'll ever write in Nginx. The hooks pick the phase: access, by Lua for gatekeeping, content, by Lua when you own the response, Lua shared.dict when workers need to share state. The APIs are your gateway through the ngx module. Read with ngx.var and ngx.req, terminate with ngx.exit, count atomically with ngx.shared, and hash deterministically with crc32 to short. Memorize these 7 names and you're fluent. Time to put hands on keys. 3 drills, escalating in realism. Exercise 1 is 10 minutes. Embed Lua. Return a string. Prove the request never touched an upstream. Exercise 2 is the real lesson. A per-user rate limiter using shared dict, where you'll watch Alice get throttled at the 6th request while Bob still has a full budget. Exercise 3 is canary routing. Hash a cookie, send roughly 5% to v2, and confirm stickiness by hitting the same UID twice. Make sure OpenResty is actually installed. Plain Nginx extras will fail on the Resty JWT bits. Once you're comfortable, the next trap is overreach. 5 mistakes turn a clean edge into a fragile JS-style app. 1. Any non-resty library blocks the worker 50 milliseconds where nothing else gets served. 2. Requires inside the hot path reload the module every request. Hoist them into init by Lua. 3. Shared dict is for counters and flags, not JSON blobs. Push complex state to redis. 4. Always wrap resty calls in pcall or one malformed token throws a 500. And 5. Keep business logic out of access by Lua. Edge does auth, rate, routing. Backend does business. And that's the shift this lesson is really about. Nginx stopped being a config file the moment you bound Lua to a request phase. Now it's a programmable platform with auth at access, logic at content, and state in shared dicts. Next lesson, we stay on that platform but swap languages. NJS for JavaScript inside Nginx, plus dynamic modules like GOIP2 and Brotli that extend the binary without a recompile. See you in Lesson 7.